Hey everyone, and welcome back to the channel. Today we're diving deep into the cosmos, but with a specific focus that might surprise you. When you think of space exploration, you probably picture NASA's rovers on Mars or the Hubble Space Telescope. But there's another major player whose quiet, methodical work is uncovering some of the universe's most profound mysteries: Japan. Japan's space agency, JAXA, has been at the forefront of some truly groundbreaking missions. They've landed on asteroids, brought back samples older than our own planet, and peered into the dawn of time. You'd think with all these achievements, the universe would be getting a little clearer, right? Well, it's quite the opposite. It seems every new piece of data Japan collects doesn't just answer a question. It unravels a dozen more, pulling us deeper into a cosmic enigma. Their story isn't just one of discovery, it's a journey into ever-deepening uncertainty. It's a tale that suggests the universe is far stranger than we ever imagined, and that maybe, just maybe, the biggest discovery of all is still hiding in plain sight, waiting in the data they've already collected. So let's start with what makes Japan's approach so unique: precision. While some missions go for grand, sweeping gestures, Japan's space science is often about incredible accuracy. Think of it like cosmic surgery. Take the Hayabusa missions, for example. The first Hayabusa was a nail-biter. It traveled 300 million kilometers to a tiny, potato-shaped asteroid named Itokawa. The goal wasn't just to fly by, it was to land, grab a sample, and bring it home. Everything that could go wrong did. Communication failed, engines faltered, but through sheer ingenuity, the team managed to coax the probe back to Earth. And against all odds, it brought back microscopic dust grains from another world. This was the first time humanity had ever brought back material from an asteroid. The analysis of these tiny specks confirmed that many of our meteorites do indeed come from these types of asteroids, linking the rocks in our museums to their origins in the solar system. It was a monumental success, built on perseverance and precision. Then came Hayabusa 2, the sequel. This time, the target was Ryugu, a different type of asteroid, darker, more primitive, and thought to hold the building blocks of life. And this mission was precision on a whole new level. Hayabusa 2 didn't just land once, it landed twice. For its second touchdown, it did something truly audacious. It fired a copper projectile into Ryugu, creating an artificial crater to excavate material from beneath the surface. Material that hadn't been blasted by solar radiation for billions of years. This was like digging for cosmic treasure, and it paid off. The samples it brought back in 2020 were stunning, over 5 grams of pristine, carbon-rich material. When scientists opened the capsule, they found something incredible. The Ryugu samples contained more than 20 different types of amino acids, the fundamental building blocks of proteins and life itself. This was a huge discovery. It strongly suggests that the ingredients for life weren't cooked up exclusively here on Earth, but were delivered to our young planet by asteroid impacts billions of years ago. These asteroids weren't just rocks, they were time capsules carrying the prebiotic soup that may have kick-started life. But this answer just leads to a bigger question. If these ingredients are common throughout the solar system, scattered on asteroids like Ryugu, then why does life seem to be unique to Earth? Or is it? Suddenly, the universe feels both more familiar and more lonely at the same time. The more we confirm that the building blocks of life are out there, the more puzzling Earth's special status becomes. And the mysteries don't stop with our solar system. Japan is also listening for whispers from the very edges of the observable universe. Using powerful radio telescopes, they're searching for messages from deep space. I'm not talking about little green men, but something far more fundamental, signals from the cosmic dawn. This is the era, just a few 100 million years after the Big Bang, when the very first stars ignited and lit up the universe for the first time. Before this, the cosmos was a dark, neutral fog of hydrogen gas. The light from these first stars is so ancient and has traveled so far that its wavelength has been stretched into radio waves. Japanese researchers are part of international collaborations trying to detect this faint, primordial signal. It's like trying to hear a single pin drop in the middle of a rock concert. The universe is noisy, filled with radio signals from our own galaxy, from distant quasars, and even from our own technology on Earth. Sifting through all that interference to find the one true signal from the dawn of time is a monumental challenge. So far, we haven't definitively found it. We have theories about what those first stars were like, that they were massive, hundreds of times the size of our sun, and lived very short, violent lives. But we don't know for sure. What were they made of? How did they form the first galaxies? Finding this signal would be like finding the universe's birth certificate. Until we do, the story of our cosmic origins has a missing first chapter, a blank page we are desperate to read. But some of the biggest mysteries aren't just far away. They're completely invisible. I'm talking about particles that pass through your body, through the entire planet, as if it weren't even there. Neutrinos. Japan is home to one of the most incredible physics experiments on Earth. The Super Kamiokande, or Super K, buried a kilometer underground in a mine. It's a colossal tank filled with 50,000 tons of ultra-pure water, lined with over 13,000 light detectors that look like giant golden eyes. Its purpose? To catch the ghost-like neutrinos. These particles are produced by the sun, by exploding stars across the galaxy, and by cosmic rays hitting our atmosphere. Super K detects the faint flashes of light produced when a rare neutrino happens to interact with a water molecule. By studying these flashes, scientists have made incredible discoveries. They proved that neutrinos have mass, and that they can change flavor, or type, as they travel. A Nobel Prize-winning discovery. But this too has opened a can of worms. The standard model of particle physics, our best theory for how the universe works, assumed neutrinos were massless. They're not. This means our most fundamental theory is incomplete. There's new physics out there beyond what we know. Furthermore, we still don't know why there is more matter than antimatter in the universe. Some theories suggest that neutrinos could be the key to solving this existential puzzle. Super K is hunting for clues, but for now, these invisible particles just point to a vast, invisible world of physics we have yet to understand. Now, let's return to those dark asteroids, like Ryugu. The name Ryugu itself comes from a Japanese folktale about a dragon palace at the bottom of the sea, holding a secret treasure. A fitting name, because these dark, carbonaceous asteroids are one of the solar system's biggest secrets. They are blacker than coal because they're rich in carbon and organic compounds, but they also contain water locked within their minerals. This has led to the dark asteroid paradox. Here's the problem. These asteroids formed in the cold outer regions of the solar system, yet the minerals inside them show evidence of having been altered by liquid water. This means that at some point in their distant past, these frozen, rocky bodies must have been warm enough to melt their internal ice and have liquid water flowing inside them. How? The leading theory is that radioactive elements within the asteroid's core generated heat, turning it into a short-lived, warm, watery world on the inside, while its surface remained frozen. It was a geologically active body for a brief period. So these dark, dead-looking rocks were once dynamic little worlds. This completely changes our picture of the early solar system. It wasn't just a collection of cold, inert rocks. It was filled with millions of tiny, temporary water worlds. Each one could have been a potential incubator for prebiotic chemistry. This discovery from Hayabusa 2's samples doesn't simplify things. It multiplies the possibilities and the mysteries exponentially. Finally, we arrive at the biggest puzzle of all, the early universe. Japan's Subaru telescope, perched atop Mauna Kea in Hawaii, has been instrumental in mapping the most distant reaches of the cosmos. Its powerful cameras can capture light from galaxies that are over 13 billion light-years away, giving us snapshots of the universe when it was just a toddler. These surveys have helped us create a 3D map of the large-scale structure of the universe, showing how galaxies are arranged in immense filaments and voids, like a cosmic web. But here's the kicker. The more we map this structure, the more we have to confront the two biggest elephants in the room: dark matter and dark energy. The way galaxies spin and the way they cluster together in this web make no sense with the amount of visible matter we see. There has to be an enormous amount of invisible matter, dark matter, providing the extra gravity to hold it all together. And the expansion of the universe isn't slowing down, it's accelerating. Something we call dark energy must be pushing everything apart. Together, these two mysterious components make up 95% of the universe. All the stars, planets, and galaxies, everything we can see, is just 5% of the total. Japanese telescopes are helping to map the 5%, but in doing so, they are really just mapping our own ignorance about the other 95%. Every distant galaxy Subaru photographs is a testament not just to what's there, but to the overwhelming majority of what's missing. So, from asteroid time capsules carrying the seeds of life to invisible particles rewriting our laws of physics, and from the missing first chapter of the cosmos to the dark forces that govern its fate, Japan's space research is a masterclass in cosmic humility. Every answer they find beautifully, and sometimes frustratingly, reveals just how little we truly know. It's a reminder that the universe isn't a problem to be solved, but a mystery to be savored. And perhaps the most exciting thought of all is that somewhere tucked away in an archive of data from Hayabusa 2 Super K or Subaru, a single data point is sitting there holding the key to the next great revolution in our understanding. We just haven't found it yet. What do you think is the biggest mystery in space? Let me know down in the comments. Thanks for watching, and if you enjoyed this journey into the unknown, be sure to like and subscribe for more deep dives into science and exploration. See you next time.